Okay, so I'm Hugo from the Shadow Robot Company. We've built some hopefully exciting piece of hardware, and we want to do a quick advertising and say that we have a consignment program. So first off, what's RunX? So basically, with RunX, you can connect your hardware to ROS. When you build robot, when you prototype a robot, you usually build lots of electronics, then you write lots of drivers, and you always do kind of the same thing, but not exactly the same thing to get your driver integrated into ROS. And then after a few months, you say, okay, now I can play with all the things I wanted, move it, etc., navigation stack. So that's a pain. What we did is do a small module, and you connect your inputs, your sensors, you connect your motors, etc. You write no lines of code. You can have a full joint-based robot, for example, with just writing URDF. We have custom transmissions, so you just write your URDF, and you're good to go, and you can control your robot. Success story, one of our production engineer had an arm moving in MoveIt without my team, so the software team, spending 0 hours of programming for that arm. So that was like really cool success story. We see it as a minimum viable product accelerator. You're a company, you want to prototype a robot, see if it works, get the RunX, plug in your sensors, plug in your stuff, and you can show to some people, okay, look, my idea is working. For now, we have a generic input-output module. We have an SPI module, which talk to different SPI hardware. There's plans to do other boards to talk to stepper motors, etc. That's in development. So now we come to the consignment program. The idea that you can try the RunX for free for 3 months. You get a support engineer at Shadow. You have his name, you have his email address. You can pester him. He's going to answer your question. At the end of the 3 months, you can pay for it or you can return it. So if you're interested, you get in touch. I'll forward you email to whoever is in charge at Shadow of this thing. So yeah, contact me. You can come see the RunX, the exhibition booth as well. Yeah, go to our website, buy RunX's. It's awesome. That's it. 19 seconds left.
All right, Andy Wilson. And just a note, we'll hold all questions until the end.
All right, hi everyone. My name is Andy Wilson. I'm a graduate student at Northwestern University, and I want to quickly highlight a Python extension module that our lab developed over the past couple of years. Jarvis Schultz is also a member of that lab, and the PI is Todd Murphy. So this is a simulation and optimal control package. So what's different about it versus Bullet, ODE, some of the other physics engines that are used? TREP uses a tree structure, system definition, which is helpful to cache the system as you update it when you're going from state to state. One of the big differences is it uses symplectic integrator. Normally, if you know how integration methods work, a lot of ODE runs on RK4 schemes or Runge-Kutta schemes. This uses a different type of integrator which has stable long-term energy behavior. So I can talk more about that if you're interested. Just find me. It also includes Hall number constraints, external forcing, and it scales really well. We can do 30, 40 degree of freedom systems for rigid bodies in real time with normal computing. The optimal control side of it, we can provide first and second order derivatives for the systems, both in continuous and discrete time. And we have a projection-based form of optimal trajectory optimization. So this is for nonlinear systems. This is a simple cart pendulum system. We have a mapping that we did a ellipse in a vertical plane. And we're just trying to do a simple sort of tracking problem, and TREP solves this very well. Just to highlight a few of the projects that we've used this over the past couple of years, on the top is a rendering of a marionette project, autonomous marionette project that we have worked on in collaboration with Disney Research. And on the left-hand side is a visualization of TREP, and on the right is the marionette system. TREP in Python can be used either with ROS or outside of ROS. So in ROS, we've been using it in a crane control problem. So on the bottom left-hand side, we can draw trajectories and run a receding horizon controller using the optimal trajectory control. And on the right, we've just started dabbling a little bit in quadrotor flight, and so we can generate these LQR-based controllers for quadrotors, coupled quadrotors, and looking into flight for those. So if you're interested, be sure to check out the website. You can find all the code on GitHub through this link, nxr.northwestern.edu/trep. If you're around for the workshops on Thursday, Jarvis is going to be giving a talk at the real-time motion generation control workshop. There's also a few papers you can reference, or just find one of us afterward. So thank you very much.
All right. Hello, my name is David Liu. So one of the things that we saw from Tully's recent metrics post about ROS is that we have ROS users all around the world. And related to that, as a side project back when answers.ros started up, I created a collaborative Google map that was attempting to track all the ROS users in the world. Turns out some people vandalized that, and there's University of Arizona is not off the coast of Puerto Rico. So came up with a new solution that is a open source map of all the ROS users that have registered. So this is all on a GitHub project, and it dynamically generates all the posts from the data that people have submitted. Unlike previous versions, this is, all the data is kept with everybody's favorite markup language, YAML. And so the point of this is really just to encourage you to add your group, yourself, or whoever to put your spot on the map and create more of the community that we have all come to appreciate. It's also all open source, so that if you would like to add something to the map, you are free to. Vincent wanted to see what the breakdown of different types of groups were, and so he added the pie chart there. I'd also like to add an extension that shows you where the space station is relative to the map, so that we can see where ROS is running above the Earth. So put your put your business on here, and then we can not only appreciate the extent of the ROS community, but if per se you were looking for a job in a particular geographic area, it would also help you find that. Thank you. Lee, come on up. Since everybody seems to know the schedule, you can probably just come up here when the guy's finished before and press the right button. That's all I'm doing right now.
Perfect. Hi, I'm Lee Rudden, CTO and co-founder of Blue River Technology. I think technology can really improve the sustainability and the production of agriculture. And by building robots that can see, identify, and act on plants, you can make a big difference. And what we do is we're building our first generation of product is a lettuce thinner, and this is our fourth version of it. And it can go out and it can see, it can act on around 1 million plants per hour, and it has the computing power of about a 10-year-old supercomputer. And if you've had lettuce today, did anybody have lettuce today? There's about a 2% chance that we did an operation in that lettuce, and I think that's pretty darn cool. And here in about 9 months, there's going to be around a 10% chance. So you can imagine how big of an effect this is having in our daily lives, and that people in this room are affected, and you have no idea about this part of the technology. And to me, that is really darn cool. And if you want to talk more, I'll be around the rest of ROSCon and the first part of IROS. Thank you.
Hello, I'm Aaron Rothmeyer with SICK, and I'm not a software engineer. I thought you guys should know I'm a hardware guy. I do LiDAR. I do the laser scanner products at SICK. So why would I come here to a software con? Well, I'm here because I feel that I need to be here. I need to be here to be involved. I need to be here to learn. I need to find out more about ROS. Because I think in the coming years, you know, we've already been here for 7 years, I think coming up, this is going to be really the only logical way to form a robot, you know. And so we want to be a part of that. And I'm here because I want to let you know that SICK is listening. SICK is paying attention to what you guys are doing. So, so who is SICK? For those of you who don't know SICK, we've been around. We were founded in 1946 by Dr. Erwin Sick. That's where the name comes from. Not an acronym. It's the founder's last name, Dr. Sick, German. A German company. So he started out, he wanted to do optical systems. He wanted to do sensors and that type of thing. And over the years, those sensors have grown into a variety of products, including laser scanners, time of flight, LiDAR devices, whatever you want to call them. So over the years, we found ourselves in several interesting applications, including the DARPA Urban Challenge. You can see us there up on the top, the laser scanners there. We found ourselves on some Boston Dynamics projects that we're very proud of. And if you ever see the Google Street View car roaming around, we've got 3 on the top of every one of those. Also, if you paid any tolls on the way here, that was probably part of our doing as well. We scan the cars as they go underneath the overpass. So now that we've done all that, now with more than 20 years of laser scanner experience, we want to do things better. We want to make them smaller. We want to keep our industrial roots, but we want to make things small. So this is a TIM laser scanner. It's been on the market for a couple of years now. We already have 5 models available. They range up to 10 meters in range, indoor and outdoor. But we want to take that and we want to do even better with it. So we're involving ourselves with the ROS community. We've donated devices to Brian Gerke and his team so that they're available to you. So you can see stuff like the LMS5, the LMS1, you know, our big bad boys. And then we have the TIM, the small one as well. So what we're hoping is that by involving ourselves with your community and allowing you to test these devices, we can get some feedback from you. We can find out what you think about our devices, and in turn, we can give you an opportunity to find out just how killer our hardware is. So already, you've asked for better resolution, and we're happy to say that by the end of the year, we'll have one of these out with 1/3 of a degree resolution. So take advantage of what's available. If you have any questions, feel free to hook up with Daniel, who's the global product manager, or Andrew, who's our West Coast distributor. Thank you very much.
Hey, that's not me. Nope, that's me. Hi, I'm Vincent Trouble from the OpenCV Foundation. I just wanted to announce that OpenCV 3 Alpha just came out a few days or weeks ago. Yeah, finally. So we don't have much money, but actually the community has been great, and there's still a lot of development. If you're looking for things to do in Vision, please contact us, and we'll see what we can do for you. OpenCV 3 is mostly an API cleanup. If you hated the macros, if you hated the things that don't belong to namespaces, yeah, all that has been cleaned up. It's going to be much easier to go from 2 to 3 than it was from 1 to 2. A lot of performance improvements too. OpenCV, OpenCL, GPGPU, all that really have great improvements there. Just look at the release notes. A lot of new features. For robotics, what's cool is like there's finally support for RGBD, visualization too, text detection and whatever, object recognition too. I finally put it in Indigo last weekend. I haven't tested it at all, so please, you know, try it out and let me know. And big announcements. On Monday, I think we're going to announce the challenge. I think it's financed by DARPA. But basically, we want people to beat state-of-the-art results on 10 different challenges. There will be 5 winners, 10K each. This includes SLAM, object recognition, a bunch of those. So if you're working on that, just wait for the announcement on Monday. It's going to be a bit everywhere on ROS Users. I will put it there. And that's it for now. And I'm Vincent Trabot from Aldebaran, previously called Aldebaran Robotics. We do not support ROS yet officially, but that doesn't mean that we do not help the community work with ROS. There was a lot of great work done by a bunch of people, Armin Horning, among others. And what we have now is actually a much better URDF, which is auto-generated from our data. So, you had a lot of TFs missing before. Those are here, real values. The meshes are also available, which wasn't the case before. You had the funky cylinders from Armin, but now you can have the real meshes from now and for Romeo too. The bridges are much better. Sensors that were missing before, like sonars, well, they're here now, so you can play with that. There's also an RQT dashboard, which has been revived, so you can see the battery state and all these things. There is support for MoveIt. We haven't released the packages yet, but please stay tuned. It's going to be out. Actually, we just released it for Romeo. And also a Gazebo plugin, which maybe a few of you have implemented one, but this one actually has real PID values for the motors. We've measured them, so it's actually very good support. And as I said, Romeo also has just some support. So please just join the SIG. There's a lot of really nice stuff happening there. For example, somebody created a 3D printed helmet to add an Asus on top of the Now, or even a backpack that supports an Android to get a bit more beefy power there. And that will be it for today, I guess.
All right. No picture. My name is Austin Lawrence. I am co-founder of Future Tech Farm, and I'm the tech guy. I'm also a Master of Science and Robotics student at Northwestern. I just wanted to pitch my company and let you guys know what we are working on. The issue that we're trying to solve is that farmers today, to meet the growing demand of produce, often have to harvest their product prematurely and ship it tremendous amounts of distance, which leads to carbon waste, and also by the use of controversial fertilizers and pesticides to grow their product effectively. The organic industry is growing at about 14% a year. It's valued at about an $80 billion industry in the US, and there's projections that it'll continue that pace for the next 5 years. Future Tech Farm is addressing this through strategies in controlled environment agriculture, which is the idea of controlling as many parameters as you possibly can, temperature being probably the biggest bang for your buck, but also anything that pertains to the environment. So the pH of the water that you might be supplementing your plants with, the nutrients that you're giving it, even the wind that you might be supplementing to make these plants sturdier. There's a farm that we're working closely with called Green Spirit Farms in New Buffalo, Michigan, and they are farming at an efficiency much higher than what you can get from conventional farming. They're actually farming in vertical layers, and with a 30-foot ceiling, multiple stacks of lettuce pallets, they're able to accomplish about 300 times more produce per square foot compared to conventional farming. That's because you're growing year-round. That's because you're in a very controlled environment. We've gone ahead and developed a project called Galileo, which utilizes sensors to monitor the parameters for these hydroponic grows, and then transmits data to your phone or whatever medium you wish. And the future goal is to integrate autonomy into this. So as a robotics student at Northwestern, I'm hoping to gain better insight as to how to accomplish this, and more importantly, just looking to network and have some conversations with people. So thank you.